This is lesson 1.5, Measuring Angles. Essential question, how can you measure an angle and use the angle addition postulate? Let's go to our notes again, setting up the title and the essential questions. We are going to have vocabulary, we're going to have a postulate, actually two postulates, and a definition. Leave room for some examples. Naming angles. So this first vocabulary word, and you need to draw the picture. And you can see that there's different parts to the angle. This part is called a vertex, and these things are called the sides. We have different ways to label the angle. One is we can label it by its vertex. The other way is to label it with 3 letters, the middle being the vertex. So under notation, you should be writing these down. And there's one more way to label an angle, and you can label in the interior of the angle a number, and that angle is named by that number. So we can say angle 1. This portion is the interior of the angle, and this portion is the exterior of the angle. Make sure all that gets written in your notes. Okay, here's an example. We have 3 angles here, and we would like to name all 3 angles. Okay, so I'm going to try to name this angle right here. And I cannot say angle M because you would know that I was talking about this angle, the other angle, or the big angle. So in this case, I have to use the 3-letter option. So I'll say J, M, K. Now I could reverse J and K, but M still has to be in the middle. Now this is the other angle I want to label. So I'm putting these tick marks here so you know what I'm looking at. And again, we're not allowed to use 1 letter. We're going to have to use 3 letters, and I'll say K, M, and J. The M has to be in the middle. The K and the L could trade places, but the M still is the vertex. Now, the last angle is the big angle. And I'm going to use 3 arcs here so that you understand it's not the same as these other 2. And this will be angle J, M, L. And again, you can exchange the J and the L, but the M is required to be in the middle. Okay, I'd like you to try it. Stop the screencast, see if you can write 3 names for the angle, and let's see how well we match. Here are the answers. All right, now let's talk about measuring. We want to find the degree measure for each one of these angles. Now, in a protractor, there's actually 2 scales, and I will read the top scale here. So I'm going to ignore the bottom scale. So this scale has the number 180 associated with this point A, on this side, and this side of the angle is, it looks like 145. It's between the 140 and the 150. This one looks like 115 because it's between the 110 and 120. This is 70, and this looks like it's 35. And we don't need anything here, but that's 0. Okay, we would like to figure out the measure of angle AOB. So we're going to take these 2 measurements, 180 minus 145, and we are going to get 35. So we say that the measure of angle AOB is equal to 35 degrees. Now, notice that I'm using the little m. Measure means that we're talking about a number that's associated with how wide that angle is spreading out. Angle COE. All right, C, O, and E. Now C has the 115 associated with this side of the angle, and this side of the angle has the 35, and I'm going to subtract these, and I'm going to get 80. So the measure of angle COE is equal to 80 degrees. Again, it's important that you put the little m. The m says we're talking about a measure. If you leave the m out, we're talking about a set of points. Okay, BOC. B is 145 and C is 115, and it looks like the measure of angle BOC will be equal to 30 degrees. Now let's take a minute and see if we can't do this another way. BOC. Okay, so you can see that this is 5 degrees. So 5, that's 5, 10, 15, 20, 25, 30. So you can see we have 6 intervals of 5, and we got the 30. Okay, B, O, E. Okay, B is 145, and this side is associated with 35. So the measure of angle BOE is equal to 110. And again, if you don't want to subtract these two numbers, you can go by intervals of 5 or 10 and figure out the answer as well. Okay, so what have we been doing here? Well, we've been doing the protractor postulate. Remember, we had another postulate which is called the ruler postulate. It associated points on a segment with a coordinate. Well, the protractor postulate associates the side with some number in the protractor. And when you line up these numbers with the sides, you can use them to help you find measure. And again, here's another note. When we're talking about measure, we have to use the M. All right, here's the name of 4 angles that we work with. I'm aware that a lot of you have had this vocabulary before. If you haven't, then you're going to have to take time to write this down in your notes. Okay, here's an opportunity for you to find the measure. Stop the screencast, see if you can find these numbers, and check your answers on the next screen. Here are the answers. And I put the absolute value there just in case I turned around the numbers and I got a negative number. Remember, measure of an angle will not be negative at this point that we're talking about in our course. And notice I wrote obtuse, acute, and right, depending on its measure. Okay, identify the congruent angles labeled in the quilt. Okay, you can see there's no measures here, so let me talk about what we see here. This is a tick mark. It's really an arc mark, and that arc mark is duplicated right here as well. So what they're trying to tell me is, they're trying to tell me that angle G has the same measure as, let's see, angle B. And when they have the same measure, their sets of points are going to match up. So we say those angles are congruent. Now here's some other arc marks, indicators that angles are congruent. And I'm going to say angle F is congruent to angle D. And again, when angles are congruent, their measures are the same. Okay, it says that angle ADC is 140. So this angle right here is 140 degrees, and they would like me to find EFG, and that answer will be the same. The tick marks reveal that they are congruent, and when they're congruent, they have the same measure. All right, let's take a look at this situation. We are trying to find the measure of angle, let's go ahead, this measure of angle ABC. Notice how I'm following the letters to help me see what the angle is. It's a big angle. And so the measure of that big angle is the sum of the two little angles added up together. And so this answer will be 58, and then the answer is degrees. They'd like me to find L, M, N. Start with L, M will be the vertex, and then N. And again, this is a big angle. So the measure of angle LMN is equal to 85 plus 23, and so this answer will be 108 degrees. This looks like that segment addition postulate when you add the two little things and it makes a big thing. And that's what this one is called. It's called the angle addition postulate. When you have two angles right here that share a side right here, then we say the two little angles add up to the big angle. And this is called the angle addition postulate. All right, so how would I do it in this problem? They're telling me that LKN, this big angle right here, is 145. And they'd like me to figure out these two. So I know that these two angles have to add up to 145. So it's an opportunity to use some algebra skills. We're going to add up the x's. That's 6x. Add up the numbers. That's plus 7 equals 145. 6x will be equal to 138. So x is equal to 13. Now we're going to put 13 into here so that the measure of angle LKM is equal to 2 times 13 plus 10, which is, this is 36 degrees. Now I can go ahead and put 13 in here, but I know it has to be the leftover from 145. So when I subtract 36 from 145, I'm going to get 109. So the measure of angle MKN is equal to 109. Those two have to add up to 145. All right, your turn. You have some hints here. You know that you have a straight angle and you know you have a right angle. Stop the screencast, see what you can do, and then compare your answers with mine. Here are the answers. All right, as soon as you figure out what x is, you need to put x into the expression for these angles, and then you find the angles. Okay, let's talk about an angle bisector. That's the vocabulary word. That should be in your notes. You should copy the picture. And an angle bisector, similar to a segment bisector, it cuts something into two congruent shapes. In this case, it's two congruent angles. And when the angles are congruent, their measures are the same. So here's an example right here. BD is cutting this angle into two congruent angles. So this angle and this angle are going to be congruent. Notice how I use one tick mark or one arc mark to indicate this is the same size as this. So I'm going to set them equal to each other. And I get 3x is equal to 15. So x is equal to 5. Now it's asking me to find this angle, ABD. So I'm going to take the measure of angle ABD, and it's going to be 6 times 5 plus 14, which is 44. Now I know the other angle, DBC, also has to be 44, because remember they're equal to each other. And so therefore the big angle, measure of angle ABC, must be equal to 88. All right, and we're not going to do the next problem. All right, see what you can do on this problem. You're going to have to draw yourself a picture. Stop the screencast. When you're ready, go ahead and compare it to the next screen, which has the answer. Here is the answer. I went ahead and drew the angle bisector, made sure that I understood they were both the same. I went ahead and labeled the answer, and then I was able to find the answer. Okay, here's your last opportunity. Find the measures of angle ABD and angle DBC. Stop the screencast, figure out the problem, and then start it again to look at the answer. Here's the answer. You need to use the angle addition postulate. So we know the little angle, have to add up to the big one. This is the end of lesson 1.5.